Good morning! Yes, it is morning, which is why I'm forcing my voice to be a little bit more peppy than it normally would, because I normally am like a dead person in the morning. But anyway, suppose that we have an equation that is y is equal to 3 to the x power. So I'm going to write down some x values that we're going to plug into this equation. 3 to the negative 3 is going to be this decimal 0.0370. Negative 2 will be 0.111. Negative 1 will be actually 1/3, which is 0.333. And then 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27. So what we're going to do is we're going to plot all of these points on an axis, right? So I'm going to start with x value negative 3, which is a very small decimal there. And so is negative 2, so is negative 1. And then we get 1, we get 3, we get 9, and then 27 is way up there, so I can't really graph it. And we're going to just connect these dots, and I get this shape that is the exponential equation, okay, where we start off kind of like very rapidly approaching the x-axis, as you can see from the left side of the graph, and then it shoots up super high on the right side of the graph. Okay, so an exponential equation is just in the form of y equals b to the x power, where b would be some number greater than 0, and it's also not equal to 1, because 1 to the 1 power is just 1, 1 to the squared is 1, and 1 cubed is 1, right? So that wouldn't ever do anything except stay at 1. So y is equal to some number that's not 1, and then to the x power, some positive number. Now let's suppose that I graph another equation that looks like this. It's kind of like mirrored across the y-axis. This would actually just be the equation y is equal to 1/3 to the x power. So it's just the reciprocal, right, which kind of turns it around, flips it around. So here we have the ones that are b is greater than 1 are going to look like the blue line there, and then if it's between 0 and 1, then it's going to look like that purple line. Okay, let's go ahead and do some examples together. Let's suppose we have 7 to the rad 5 power times 7 to the rad 2 power. Actually, that might be a rad 3. Yes, it is a rad 3. Okay, recall that from our rules of exponents that if I have the same base, I can add my exponents. So this would be 7 to the power of root 3 plus 2. Now, if I have 7 to the power of root 3 and then raised to the power of 2, remember that I can multiply my exponents together, which means it would be 7 to the 2 rad 3. And then I can actually apply that square to the 7 and make it 49 to the rad 3. Let's go ahead and do this next example. The first thing I'm going to do is I'm going to change 49 to be 7 squared. That way I have the same base. And because I have the same base, I can actually subtract their exponents. So if I subtract their exponents, I get 7 to the power of rad 3 plus 2 minus 2, which those 2's cancel out, and I just get 7 to the power of root 3. Excellent. Let's go ahead and do another example with a different sort of radical. So here I have the cubic root of 4 to the 6 pi, right? So the first thing I'm going to do is I'm going to change that cubic root to 1/3 power. And then what I'm going to do is I'm going to reduce that fraction at 6/3, which is just 2. So it's 4 to the 2 pi, which I'm going to apply that 2 to the number, so I get 16 pi. Next example, I have some kind of complicated thing in the parentheses here to the 2 plus pi and then pi, but I notice that these are the same base actually, right? It's just root 2 minus 1 in both cases, which means I can take root 2 minus 1 and just raise it to the 2 plus pi minus pi, which is just squared, right? And then I can expand this to root 2 minus 1, root 2 minus 1, which I end up with 2 minus root 2 plus 1, which ends up as 3 minus 2 root 2. Okay, so kind of recognize that you might have the same base even if it looks kind of complicated, right? They might be the same base and you can simplify from there. Let's suppose I want to solve this equation, which is 5 to the x is equal to square root of 125 power. I'm sorry, not 125 power, but square root 125. So let's go ahead and go over a quick rule. If I have b to the q is equal to b to the p, this is true if and only if their exponents are actually the same, right? So q should be equal to p. So what I'm going to do is I'm going to try to make both sides of this equation have the same base of 5, right? I notice that 125 is actually 5 cubed, and so the square root can be written as a fractional exponent, which is going to be 3/2, right? 3 over 2, and then I get x is equal to 3/2 because their exponents have to be equal because it was 5 to the x equals 5 to the 3/2. Okay, let's go ahead and do another example where we have to get the exponents equal to each other, or their bases equal to each other, so that their exponents should be equal to each other. First, I'm going to substitute so that y is equal to 3 to the x, and y squared would be equal to 3 to the 2x. So I end up with an equation that's y squared minus 10y plus 9 is equal to 0. This can factor into y minus 9, y minus 1, which means y is equal to 9 and 1. Okay, so 3x is equal to 9, 3 to the x is equal to 1. So I need to make the 9 and the 1 have a base of 3. Well, 9 is just 3 squared, which means x would be equal to 2. And 1 would be actually 3 to the 0, which means x would be actually equal to 0. Okay, good luck on your homework and have a fantastic day.